I'd like to remind you that at 6:30, auditorium number 1 will deliver the Excellence 2004 award for PU, composites, and engineering plastics. Next talk is from Lanxess. I'm waiting for Jean, the speaker, and we'll start soon. Thank you. Jean Paulito is well known in the market. He said everybody knows him. He's going to give us a talk from Lanxess and tell us how PU elastomers from Lanxess can help your company. Thank you, everyone. Good afternoon. I apologize for being late. So the idea here is to show you our elastomers. This is the elastomer trade show. There's a lot of interesting things, and please visit us. As my friend mentioned, I'm Jean. I work in the technical area since 2006. I had a little more hair back then, and I'm going to talk about the launches, the news, and the trends. So I'm going to talk about Lanxess. It's a German company. It came from Bayer, spin-off from Bayer in 2004. It's a chemical industry. And it has a number of products in its line as intermediate chemicals, additives, specialties. And nowadays we have approximately 13,000 employees in 32 countries. Global sales approximately 8 billion. As any other large company and chemical multinational, the idea is to strengthen its position in the markets where it operates. And the technical area really helps us to strengthen that. In Lanxess, we have 10 divisions, 10 business lines that are one is very different from the other. And urethane, the last square, is our business unit. I really like this chart. It shows us the pillars. Be a resilient supplier, and that's important for any company, of course, but we do live that. Safe and sustainable plants, climate protection, and energy efficiency. I'll go into the details about that. And always to motivate employees to have teams that perform well, that deliver well, innovation. If you take a look at our booth, we have a lot of new things, a lot of interesting things going on. Products that are in the oven, so to speak, about to be launched. Sustainable products, and we always value customer relationships. For those who work at Lanxess and our customers that are closer to us know that we practice what we preach. And this last chart here about the CO2 emissions, Lanxess is committed in Europe and to no longer have CO2 emissions be neutral by 2040. 2040 is a little far, but in Europe actually it's 2050. So Lanxess is going to comply with that 10 years in advance. So we have many pillars to achieve that objective. Do things that will have a great impact on CO2 emissions. Dissociate emissions and growth. You don't necessarily have to have CO2 emissions to grow. And technological innovations. That's what we strive for. It's very important to us. Now let's go into urethane. That's our business unit at Lanxess. It's a global company. We have plants, laboratories, and application and development centers and R&D all over the globe. So we exchange a lot of information with our colleagues from other labs. That's very important for our growth, to always bring in good things to us. On this chart, we can see our story. We have 6 production plants globally, 7 development and application centers around the world. R&D center is located in the US. Over 500 products and 360 employees approximately in urethane alone. So this is one of the slides that I like the most. It talks about the technical department. So currently we have R&D in the US, in the state of Connecticut, and it supports all the other development and application centers. They're currently divided into the Americas, where we have the US and Brazil. Ours here in Brazil is located in the city of Porto Feliz. It's close to Sorocaba, for those who live in the state of São Paulo. In Asia, China, Australia, and Europe, Italy, and England. What I really like about this slide is that currently Brazil is developing more products and launches more products than all the other labs altogether for Lanxess urethane. Okay, great, but why? We have a different way of working. Our personnel has a lot of access to end users, so we really understand our customers' needs, the end users' needs. So we already know what the future problem could be, and it helps us to develop new solutions, excuse me. It's not that our colleagues don't do that, but they do that less than we do. So we visit mining companies, we visit Petrobras, so we have a great relationship with the big customers, and that really helps a lot in developing materials. I'll talk about our framework in Brazil. We have a new modern plant in Porto Feliz. If you're older in the market, you know where we used to be in the interior with the new plant. In the lab, we have a training room that we can train up to 10 customers, or 10 people actually at the same time. And the success of our customers comes from them truly understanding what they have to do, what materials they should use. Our lab is very modern. We have a 20-liter pilot reactor. It's small. So when we start testing, and a bigger reactor for 200 liters. After the first phase, we go into the second phase. All the equipment that's necessary for abrasion, elongation, resilience. The equipment on the top right is infrared, and that's very important so that with the small samples we can determine which product it is and the chemical base. We have an Instron, and our colleagues are over there. It's a great dynamometer, and we have a manual mixer. We have 3 in the lab actually. That's a 10 kilo one. It'll mix 10 kilo, one for 1 kilo, and one for 500 grams. So our labs are a one-stop shop. Now, we can't say much about elastomers without a brief summary. So our product is divided into 2 parts, part A and part B. A, we call it a pre-polymer. which will basically be the reaction of a polyol that could be ether, ester, or caprolactone with isocyanates, TDI, MDI, PPDI. And in the mix of those two, we can obtain a prepolymer. So with that simple design, you can understand the reaction of the prepolymer in our plant. So polyol isocyanate into the reactor, and they connect and they bind to the ends, and that's where we have our prepolymer. So that's the molecule, and on one side we have an NCO molecule, and the red ball, the other NCO, which is nitrogen, carbon, and oxygen. And B, we have the substances, the curates that will react with the prepolymers, forming polyurethane. So we have amina, diol, thiol, and polyol that can be used as a cure. In other markets, they call it chain extenders. The main ones used, Duracori, there are over 70 types of cure, 500 types of prepolymers, and all of this is a lot of products. You can do a lot. I like to say that people that understand all about prepolymers, they only understand 15% because it's a lot of information. You can't really know it all. So part A, part B, now let's see how polyurethane is formed. So this is what our customers do. We have the amount of prepolymers, that's the first molecule, do the calculation and see how much of a cure you have to add. And after that, you'll have polyurethane. Very simple. What, or excuse me, why do we have so many different types of material? On the polyol side, I'm going to talk about ether and ester, but on the ether side, we have PT Mag, and when we use these materials, we say these products are high performance. 650, 1,000, and 2,000, that's the molecular weight, or size of the molecule, excuse me, and we have PPG. When we use PPG-based raw material, we call that medium performance. For the esters, we use two types, PAG and PBAG, but both deliver high performance. So it's important to understand that when we talk about polyol, there's a number of different options, and you can mix PT Mag with PPG. You can mix different molecule size. That's why there is an infinite number of products. In a simplified way as well, we have isocyanate. Here in Brazil, it's most common to see the TDI line, but we also offer the MDI line. We have TDI 100 and 80/20. When I want high performance, it's always TDI 100, and if it's medium performance, it's the 80/20. Likewise, with MDI, we have pure and modified, polymeric as well. Although we do use these two more often in our plant. When I want high performance MDI, we're going to use pure MDI. That's why there's an infinite possibilities and a number of different products.
Those who are our customers and those who aren't, in some way, we were able to create a formula for success. So our customer can sell well and with quality at a good price. We split this in three parts. Traduzido, please. And I have to. It's fast, but I need to go at 60 miles an hour. I can't. If I have a Beetle and I have a road that can drive at 300 miles an hour, it's not right. So choosing the right polymer is the means for success. And to choose a polymer, you have support from our company. Those who work with us experience this. So we always bring innovation, we have technical support, we visit the customers, we teach them how to process. They send a video saying, no, I have a problem here. How can we solve that? Do this, do that. So when you buy material from Lanxess, it's not just material. There's a whole pack of things that go with it. And this is our knowledge. But this success I was mentioning before doesn't come by itself. It will depend on our customers. It depends on you. If you buy the right product and have the right training but don't process it properly, it's not going to work. If we can go well on these 3 topics, it will work. The company will grow, it will sell well, it will sell with quality. So we believe in this chart. I also like this chart because they always ask me, where does PU come in? It fights with these 3 materials, plastics, metal, and rubber. It's a healthy fight. But as I said before, I've been since 2006 in this field, and PU has been winning these fights. So there are advantages over the other 3 types of materials that are very interesting and make the end customer choose one product or the other. So let's talk about our innovation. We're launching the flame retardant PU. Unfortunately, 2-3 years ago, in mining companies in Brazil and Argentina, they have 1 accident per year. Sometimes people die. They don't communicate it that well, but it's more common than we think. And rubber is already advanced in that. There are anti-flame rubber, and now PU is as well. It's a link. It's because of our link with the end customer. We saw this as an unmet need. We know that we have to test things, that it's not quick. Sometimes we got the fire extinguishing right, but it worsened the performance of the product. Other times the performance was good, but it was not that flame resistant as it should. It's called Vibrathane MS630F, and it's cured with butanediol. We did conducted test at IPT, which is a very well-known institution in Brazil, and we achieved V0 classification. As you can see, this is cotton. It doesn't drip, while common materials, in addition to maintaining the flame, when you remove it, it drips and catches on fire. And on the charts, between the 2 more best sold materials and Lanxess, and it maintained the same properties, but with this flame retarding property. There are three variations, V0, V1, V2, and ours was the only one that had passed as V0 at IPT. So this is the report from IPT saying that our material passed the V0 test. So this made us very proud and happy, and it's a very good quality material. It's already being sold. This mesh is at a mining company in Brazil. It's a high performance PU. The abrasion is lower than 25 and hardness of 85 short A. It's a very good material. If you go to the booth, we have materials. This is an example. We want to turn elastomer we either color it like this or with a brush. So we're changing the world of PU, and this was a development sponsored by Petrobras. Petrobras requested this. This test was conducted at Petrobras. So this is a flange painted with PU. But why would you do that? In this case, it's to protect against corrosion. So it will create a layer, a coating of 3 millimeters, and it will protect against corrosion, which is the main problem at an oil platform or companies that are located on the coast. But there are other ways of spraying where we can spray it with airless equipment, and this is to protect equipment. Those who are familiar with elastomers, you know how hard it is to mold conventional elastomer to protect this part. So this makes it much easier for our customers. This is a video of the spray painting. PUs without post-cure and without high performance. This is something that we are developing. First, we're in the MDI ether products, but we're already thinking about esters. There are two ways today creating a product with 3 components that can allow several hardnesses or one single hardness. These are the preliminary tests, where on the blue side are all the tests without post-cure, changing the hardness, and red conventional products. We had a technical tie on the properties, but here we lost. This is compression 7, which is used for, I can have a high compression set on stockpiler wheels because it would flatten the wheel. So an example where this would have a high impact is in pipes and tubulation. A tube coated with PU from beginning to end takes 20 hours. If we can make this material that doesn't need post-cure, I have the same property without post-cure that can drop to 3 hours. So the change in strategy is very interesting. And the main benefits are safety, energy savings. So I turn off one of the machines, and for the tubulation, we have materials according to what Vali likes and wants. So this is under development. Post-cure products are basically an ether, PT, MG, MDI, BDO, abrasion of less than 40, high resilience. If it's for tubulation, it's an 85 short A. Does Lanxess have this material in other countries? Yes. So why is it being developed? Because in our DNA, we want to bring always materials to be produced locally, to have a better speed to delivery. So we're creating our version based on the knowledge from our partners in other countries. Another interesting materials are the low hardness PUs. This is an innovation that has about 8 years in the market, and our customers, we're already in generation 3, even if it is established and we change to meet our customers' needs. These are high performance materials, shelf life longer than good rubber. Otherwise, we won't be able to beat them. Today we have MDI and TDI versions. Abrasion lower than 20 cubic millimeters, which is amazing. Hardness between 40 and 65 short A. High productivity and extreme resilience. So our customers, I have at least 3 examples that come to my mind, bet on this a while back, and today it changed their companies. The company is at a new level. So understanding the customer's need, having good products, having a technical group that helps you is the key for success. Very quickly, we also have a repair kit that is very interesting because it's very convenient. We have 3 components. The largest package is a 1 liter can. I mix A and B and A, and after I mix that, I mix C into AB, and it can repair rubbers like conveyor belts. In Brazil, we sell it for this application, the spirals. In mining, this piece of equipment is widely used. And the sludge that goes through here is very abrasive, and it pokes holes in the equipment. So these light colored spots here are holes. They apply the product, and the repair was only done where the problem existed. And this is the finish. And a recovered part like this one lasts exactly the same as a new part, with 25% of the cost of a new part. So this material delivers amazing results. In our idea, next year, this product comes from Australia, and I think that next year we will be producing it here. So guys, I have just a little bit of time for everything that I have to say, but the versatility, sometimes we talk about different things, innovation, this is in our DNA. Those who work with us and experience our products know this. So anything that you need, we like new things. So we dive deep, and this is part of our success. Thank you very much.